Today we are going to just finish this particular topic and then let's hope we can do it as soon as possible. So, what we're going to do is we are going to look at electrical energy and power. So, in electrical energy, we need to understand that basically energy itself is given by basically voltage times the charge. And we learned this formula. If you remember, potential difference or EMF, it was basically voltage was equal to energy per unit charge or work done per unit charge. It's the same thing. So, itself, if you look at the charge is Q and Q is equal to IT, which is current into time. So, if I want to find energy, then I have to multiply voltage with current and time. So generally we would want energy as V, I and T. So that's just that. Okay. Now of course the SI units would be the same as all energies have. That's joules. There's no difference on that. And with that said, this we can go to electrical power. Now let's see in the color. So for electrical power, we could use the same formula. We can say, okay, power is equal to energy per unit time, whereas we've just learned that energy electrical is V, I and T. So we can put it back. So power will be equal to V, I, T, and that's going to be T. So T and T will cancel out. So power will be equal to Vi, and that's what we need to remember, which is basically, let's write in words as well. So power is equal to voltage times current, like that. If you have any questions here, please let me know. So the SI units for power would be basically the same as all other powers. That's watts, written as capital W. So you got to remember that. Okay. Wait a second, please. There is some kind of issue that has happened. Okay. All right. Anyway, so then I just like to tell you that this is that. Now, the most important thing is that often we want to calculate the cost of electricity. So, I just want to ask Ali and Anaya, Caroline, Farzeen, Hussein, Shawis, everything's clear, right?
Yes, sir.
Okay. Just a second, I need to get somebody right here. Okay. So now, we are going to look at the cost of electricity. And that is very important to calculate, right? So, suppose that in a country it says that 1 unit of electricity cost 20 cents. Okay, suppose. Okay, now 1 unit of the electricity is 20 cents, let's suppose. So, what is this 1 unit? Basically, what you guys need to understand is that electrical energy is basically calculated in kilowatt and hour. Now, this unit, kilowatt hour, which is written as K, W, and H, is basically a combination of electrical energy that you're calculating, as kilowatt is in power times time, which is in time, right? Like that. So, now check this out, please. So, suppose an electrical heater runs at 220 volts and takes 13 ampere current. Okay, so an electrical heater runs at 220 volts and takes 13 ampere current. It is used each day for 2 hours and for 30 days. So, first of all, they say number one, calculate the electrical power in kilowatt. Okay, so that's the first part. And in the second part, they say calculate the electrical energy in kilowatt hour. And in the third part, calculate cost of using this heater for 30 days if 1 kilowatt hour is equivalent to 30 cents. Okay, like that. So now, first of all, we should understand that to calculate electrical power, we have the formula as power equals to voltage times current, like that. Now, voltage is 220 volts and the current it takes is 13 amperes. So, using the calculator, I don't know if it's there. I did have it, that's not fair. Okay, we gotta make it smaller. For some reason, this calculator has changed a bit due to the update to this. Okay, it's fine like this. Okay, so that means that first of all, we're doing 220 times 13, and that goes at 2860 watt. So that would be the power. Okay. Then it says in kilowatt. Now, how do we change something in kilowatt? We need to understand that when you go from smaller unit to bigger unit or larger unit, you need to divide. Okay, and it would be vice versa. It means if you go from smaller to bigger, you need to divide, and if you go from bigger to smaller, you need to multiply. Is it clear, everybody? So this means to go into kilowatt, I need to divide it by 1000 because kilo is 1000, and I'm going to get something like 2.860 kilowatt. Anybody who did not understand, please let me know. Okay. Right. All right. Zain, Moiz, do you guys understand this? Any question about it? Please let me know.
No, sir.
Now they say calculate the electrical energy. Now we already know either we can use like energies V, I, and T. But why do we use that? Like we already have the power. So what you need is we can do energy as power into time. Simple because power is VI. So the power is already in kilowatt and we just need to multiply time in hours. So it says that it is used each day for 2 hours and for 30 days. So for 30 days I can say that 2 hours, the time would be equal to 2 hours into 30 days, which means that it's gonna be about 60 hours we're gonna use this, right? So we're gonna multiply this with hours because we need kilowatt an hour, right? So then we use our calculator. Say, okay, where is your calculator? I don't know. Okay, wait. That's not fair. Okay, so for using this, we're going to say 2.860 times 60. So basically, I have used it as almost 171.6 kilowatt hour. So this is the total energy. Remember, this is the energy unit and you need to multiply the time in hours. Now, it says calculate the cost of using the heater if for 30 day 1 kilowatt is. Now this is pretty simple. You say, okay, if 1 kilowatt hour is equal to 30 cents, or we could just write for 30 cents, I think it's 0.30 US dollars, right? So we can say, okay, this is the amount. Then how many dollars are going to be used when we use this much kilowatt hours. So I'm going to multiply this. So 0.30 times 171.6, and that would cost you about 51.48 dollars. Is it clear, everyone? Any questions? Let me know.
Sir, if a question like this comes in exam, would we write in cents or dollars if they do not specify?
Usually your questions will be in pounds, right? So it will be in pounds. Okay, so probably it will be like 0 point maybe 2 pounds or something like that. So it doesn't really matter which currency it is. They will never give you like in cents or something. All right, is it clear?
Okay.
This is not maths, this is just physics, so they will just be very simple with the currency itself. Alright, so I hope you guys understand how to change something into kilowatt, how to change energy into kilowatt hour, and how to basically find the cost of electricity. That's very important. Let me know if there is a question. Hello. Walaikum. Go on. हाँ बेटा 13 लोग बैठे हैं क्लास में, उसको कहो कोई भी लिंक ज्वाइन कर लेगा, तुम्हें मिला। हाँ हाँ Okay. So now today we are going to move forward, and we basically the chapter for current electricity is finished. We wanted to go to the next one, which is basically the electrical circuits, right? But I need to restart the recording then. All right. Or should I give you a worksheet? I'm very confused about it. Let's see. Let's see. Okay, wait a second, please. It's better that I give you a worksheet before we head on to the next one, because then you might be like too overwhelmed with the questions, which is not good. Hello, Iman. Hello, Iman. You can hear me, right? Just a second. I just need to see what type of question would be the best for you. Okay, fine. I got it. So I'm gonna put it on in the classroom. Just a second. And it would be best if we finish it today till 7. We have half an hour. I'm just giving you 2 questions. I will check today within the same class. All right. Did I also assign you another worksheet last time? I think I did. Okay, so the worksheet I'm right now submitting on Google Classroom, that worksheet, you just need to do question number 4, question number 3, and question number 2. 2, 3, 4 only. Okay, so we're gonna write it. Only 2. Question 2, 3, and 4. So there are only 3 questions. Hurry up, please. Complete this.